Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to talk to you about another one of my articles. This one is entitled, "The Sun Goes Partially Dark on July 5th, 2017. And when this happens, we can see actually not very clearly, because cutoff lines are used to hide the fact that there are objects in the sun's corona, and they are also used to hide the fact that the sun is going dark. Now, the objects that these cutoff lines are used to hide are objects that are not planets. They cannot be planets, because planets in the sun's corona would not survive that environment. These objects are actually stars, and stars are at home in this sort of environment, which is at the sun's corona, which is at a temperature of between 1 and 3 million degrees Kelvin. These are objects, these are old stars, and I have referred to them in the past as brown dwarf stars. And more recently, I have used the terms stellar cores or stellar remnants. And these are stars that were once main sequence stars, but have since then started their aging process that saw them going through the red giant phase and the white dwarf phase. And after that, they cooled down and they became what I have been calling brown dwarf stars or stellar remnants. And at that time, and eventually, they were not able to emit infrared radiation. And this seems to be the state they come into the solar system. And after being close to the sun, they seem to be attracted to the sun. They start absorbing energy and plasma from the sun, and they rejuvenate and eventually are able to emit light once again. They never go back to their main sequence phase. They remain quite small, but they do start to emit some light and possibly even produce things like stellar wind. Now, in the images we're going to look at, we're going to examine the cutoff lines that are being used. And we start with these images. They are, of course, from July 5th, and they are in the 21.1 nanometer. And these are from 1627, 1632, 1637, and 1647. And we see in the first image, nothing has happened to the sun. It looks normal except for the large coronal holes. And these objects also cause these coronal holes because they connect to the sun magnetically, and so pull the sun's magnetic field outwards. I have written extensively about this. But we see the first cutoff line is introduced in the second image. It's a vertical line. It hides part of the corona. There is, of course, no reason to add cutoff lines to these images unless there is something to be hidden. So there's obviously something to be hidden in the sun's corona on the left-hand side. Then in the next image, this cutoff line is moved further towards the sun's surface. And so obviously whatever object's being hidden is moving towards the sun's surface. And then it's the vertical line still there, but a horizontal line is introduced. And we also see the corona seems to have shrunk. And the corona shrinking is possibly the fact that the sun's light emission is starting to be affected. And in the next image, we see that that is exactly the case. So this is the same image we saw in figure 1, the last one, where the sun's corona has shrunk. In the next image, we actually see this is not a cutoff line. These are cutoff lines. These are vertical, straight lines. It's darkness on one side, light on the other. These are very tidy lines. This is a very untidy or jagged line. We see some parts of the sun still emitting light in the darkness part. So this is, we can see the sun has gone dark there. It has lost light emission in the top left corner. And that's indicated by the red arrow. So the corona shrinking was an indication that the sun was losing light emission in that part. Then we look at the third image, and these are images also in 21.1 nanometer, same day, July 5th, at 1707, 1712, 1722, and 1732. And again, we have the vertical cutoff line on the left, obviously hiding something there, or the sun going dark there, or an object there, or maybe both. And then we see a horizontal line on the bottom being introduced, and we see this part here. It may be a diagonal line. There is a slight jaggedness there, possibly indicating that the sun is going dark in the bottom left corner now. And so we're going to look at some more of these images. These are, let's look at the timestamps: 1802, 1812, 1822, 1827, 1837, and 1847. So we see now the vertical line is on the right, the horizontal line is on the top. We see it looks like a diagonal line there, but when we look at this image, we see the jaggedness of the line. We see some parts of the sun still giving off light beyond this boundary. So this is a sign that the sun again is losing light emission. It's actually dark on this side, and there's light emission on this side. The next image, we see that the corona is either shrunk or is being covered because there's an object there. And these diagonal parts of the sun that have gone dark or are being hidden are indicated by these red arrows. And again, the same one, either the line has moved further towards the center of the sun, or there is a little bit of jaggedness there in the corner, indicating that the sun is going dark now in the bottom right corner. Then the next image, we see just the vertical line, and then light emission resumes, so the whole sun is now visible again. In the next images, we look at the sun in the 19.3 nanometer wavelength, and again we see the same thing happening. This is 1650, 1651, and 1652. And we see the corona seems to shrink there, and then it seems to lose light emission. We don't quite see a jagged line there, but we do have the same, well, not the same images. These are in 33.5 nanometer, but they have exactly the same timestamp as these images, and there's definitely an untidy line in the 1651 and the 1652 images. Also, we see in both of these, the middle images are out of focus, indicating that the sun was in motion or jolting at the time. And I have written about this, about the fact that the sun jolts from time to time when these objects are near it. And I don't go a lot into it. If you want to look at it, I have articles and video on this, which shows clearly that the sun has to be in motion. And the fact that the sun is in motion indicates that the sun is no longer the center of our planetary system. The other objects have joined in, and so the planets in the system are now attached to the center, which is why from Earth we can now see the sun in motion. If there was just the sun and our planets, then our planets would be attached to the sun. Whatever movement the sun would make, the planets would make exactly the same movement. So we'll never be able to see the sun in motion with respect to our planet. So I have explained this in some of the articles that I have written about that. In the next image, we see the sun in several of the different wavelengths. This is the X-ray one, 9.4 nanometers. This is 17.1, 19.3, 21.1. I'm never sure which ones are which there. So let me look. This is the 30.4. This is the 33.5, 160, 170, and the visible one, the 450 nanometer wavelength. In all of these, we see that cutoff lines, the same cutoff lines are used. These are all with the same timestamp, 1652-16, and so the same cutoff lines are used. Some of them it's quite clear from the jagged edge, from the untidy line, that the sun is going dark. So the fact that we have the same portions of the sun being hidden indicates that the sun is going dark in every single wavelength displayed here, including visible light. Then in this last figure, we have the sun in 3 different wavelengths. This is the X-ray, this is the 170, and this is the 450. And we can see that different portions of the sun are displayed in the images. So the largest part of the sun that is still illuminated is shown in X-rays. And we can see it by examining this vertical line. You see that this line here, where it meets this boundary, is longer than this line where it meets this boundary. And this line is even shorter where it meets this boundary, the curved boundary here. So the sun is, the illuminated part is larger here, it's a little smaller here, it's even smaller there. So what does this show? It shows that the sun is actually going dark at different rates in the different wavelengths. And the same thing is seen during the so-called STO eclipse season. So in conclusion, on July 5th, 2017, several objects, at least 2 and possibly 3, closely approached the sun and caused it to go partially dark at all wavelengths. In addition, the sun goes partially dark and at different rates in the different wavelengths, as also observed during the so-called STO eclipse season. I am Dr. Claudia Albers, Planet X physicist. Thank you for watching.